Yeah, good afternoon to one and all. Thank you, Venkatesh, for the brief introduction. Thank you all for giving me the opportunity to allow me to present on the basics of structural engineering. So I will be touching much on basics, how things happen in structural engineering from the inception to the end. But it's only touching the basics, and it's a big for the beginner part. So we will go very basics of the structural engineering. And coming to myself, I am Pavan. I studied my MTech on structural engineering from IIT Madras. So let's have this as an interactive session. So whenever you feel that you are having some kind of doubt or you are not getting the point which I'm trying to make, please raise your hand or please ask for an clarification. Hello.
Everyone, mute your microphones. Okay.
Yeah, please.
Please don't.
Yeah, please mute your microphones. So that's what I'm saying. So wherever you are feeling it's not getting clear. So please raise your hand or please raise your voice to make it more clear. Please help me in allowing a clear and crystal clear representation. So let's go to the basics of living first. These are the basic needs of living for any human being. So air, water, food, and shelter. So these are the basics everyone needs in any life. So coming to the basics, we will leave the other three parts because they are environment and food chain related. So coming to the main topic of shelter, when we are coming from the past, from the ages, the land is as it is. Only the population are growing if you see the population of India at 1947, it was 36 crores and now it was 140 crores. But the land of India is same as it is. So how are we going to cater this additional population? Is nothing but to give a better shelter in terms of high-rise or multi-story buildings. So coming to the initially we used to have a load-bearing walls and thatched roofs which cater to at least 4 to 5 people. Now on the same place we are doing a multi-story and high-rise buildings which cater to a bigger human being. So when I talk about density of population in initial stages were very less, and now then the shelters are very different, and now with the increase in population and increased advance in the industry market practice, so the role of shelter is going to play a major role. So how structure engineer can help the people or human beings to make the basic need achieved. So that's where this presentation will talk. So coming to the overview of structural engineering, what is a structural engineer? What do we do? What do we design? So these are the three topics which we are going to cover in this particular presentation. What is a structural engineering? Engineer is basically the mathematics of any design. It might be structures, it might be electrical, it might be mechanical. Every engineer, it's nothing but a mathematics of design. And coming to the basic need of shelter, there are four people which plays major key role in terms of getting the things executed. So coming first, the architect is the one who visions or perceives the ideology of building any structure or any bridge or any monument. So architect is the one where the vision will start, and next comes the engineer which will add the mathematics to the design, which will add mathematics to the design and then makes it executable. And next the coordinator comes between he will be the coordinating with respect to the design engineering, like engineer, structural engineer and architects, and the marketing person who actually sells your idea. So it's not always building your idea, it needs to be unit. So you need to sell your idea whatever you are building for. So doing number of building doesn't serve any purpose. You need to build, you need to have a proper vision, proper design of mathematics, and then sell your idea so that your building is getting sold to the required population. So that's where comes the vision comes from architecture, and strength comes from the structural engineering, and then coordination of between these two, and multiplied by market, whether the market availability is there and what is the requirements, and meeting the requirement is will give a start to any project. So what do we do? What do we do? That is, so we consult, we take the design perception from architect. So we will grab the vision and we will fit into the best suitable structural system to their vision. So we need to, our main role of structural engineering is to match the vision as much as possible to the best fitted structural system. So that's where we do. So that's where the key role of structural engineering happens. So that's where we fit the best suitable system for the vision depending on the requirement by architects. So coming to the same part which we do on the this design happens on the paper, and coming to the inspector which is available at sites, they actually verifies the design, or they verifies the material, or they verify the job on job practices, like how quality the things are getting planned. And that's the main about the construction phase, where structural engineer plays less role, but the main part here is about ensuring the quality and required aspects as per the design. So when we are visioning something in the design, that should be executable also. So that execution part is the major thing when we start executing. So design plus execution and a coordination between these two will only leads to a completion. Any mismatch will leads to stop of the project, or misconception of the design and inspection, or quality issues at site. So what do we design? So as I told, we got the vision from architects, and then we start quantifying the loads based on the vision. So then estimate the material capacity. So material capacities are properties of the material, and loads are the depending on the vision given by architect. So now the main part of structural engineering is to just correlate between these loads coming from the vision and estimation of the material capacities. So we correlate both. So for what load, what material is required, and for what material capacity, how much we want to make the loads. So it's a balancing between the loads and capacities is always what structural engineer works. And altogether it's about the safe and sustainable environment. So we need a safe structures and sustainable structure which has a life of 50 years or 100 years depending on the importance. So when I talk about sustainable in terms of it talks about life of the structure. It should not happen that I am building a structure which is safe for 1 year and after 1 year it is no more valid. So that should not be there. So it should be safe and it should be sustainable also. So when I talk about loads, let's go a little brief onto the loads. So that is where, so the estimation of the loads and the estimation of the material capacities is what majorly structural engineer does. So coming to the type of loads, we have many type of loads. Maybe you are all aware already that point loads, UDL, UVL, uniformly varying load. So I'm not going into much detail of this. So it's just a brief of what are the type of loads. So coming from the loads are nothing but applied on the structure. But coming to the forces, the loads, when you talk about load, what is the difference between load and force? Load is the thing, it's applied on a structure or a member. Coming to the force, what is a force? It's actually the resistance created. It's so when I'm applying actual force, if there is any resistance, when I'm applying an actual load, then when there is a resistance, the force will be created on the member. So it's actually resistance created on the member. So if I'm having, suppose let's take, I'm applying load on a chair which is having wheels mounted. So what happens? There won't be any resistance. So there is no force getting transferred to the chair. Or if I'm pushing a car which is having a zero friction between the tire and the road. So assume I'm applying so much load, but there is no friction being generated. So there is nothing the car is going to get. So it will be moving with a zero. It will be moving easily because there is no force getting transferred on it. Suppose if I'm having a chair which is having a wall in front of it and I'm trying to push, so then what happens? The chair will start squeezing itself. So that's where the force is getting transferred to the chair. That's the difference between the load and force. Load is actually what you apply, and force is what actually it takes. So if I'm applying a load, it doesn't mean always that the load is getting transferred to the force. Force is actually it is resisting, or how much it is getting transferred upon. That's what the difference between load and a force. So coming to the type of forces, so any member, this is a local behavior. So when I talk about type of forces, there are multiple types of forces. It might be tension, it may be compression. If I'm having a string in my hand and trying to push both the string lengthier, so I'm making a string of 1 meter to, I'm trying it to make 2 meters. So then there will be force created on the string by me. That is called as tension force, because I am stretching the string away from the nodes of the string away from each other. So that will create tension. And if I'm doing the same thing on a wood block, I'm trying to push the both sides of the wood blocks towards each other. So I'm trying to make the two nodes on the wood towards each other side. So that means I'm trying to compress the wood. So that's the basic ideology when we talk about compression or tension. When I'm trying to move the both sides of the block towards each other, then it creates a compression because it is getting compressed. And when I'm trying to pull the block on the both sides of the block towards other side, so that creates a tension because there are tension forces created in the member. So that is where we call compression or tension. So suppose if I do the same thing, like if I'm not holding on other side, but I'm trying to push on one side, so the wood will be moving. That won't have any force transfer. That will be we are applying a load, but there is no resistance, so there will be zero force. But if I start compressing on both sides, then it will have an equilibrium, then it will start getting forces. So if it's not stable, so there won't be any force transfer. Suppose if I'm throwing a ball to air, it will be falling down. There won't be any force transfer because it's not in equilibrium. It's moving always. And suppose the same thing when I'm trying to push or pull and it's not moving, then it's in equilibrium, and then the force will get transferred. So that is the difference between the equilibrium and unstable and stable equilibrium. When we talk about stable, there will be a load which is transferred to the force, but when we talk about unstable, there won't be any load getting transferred to a force. So that is the difference between the stable and unstable equilibrium. So what we designed was safe and stable. So that should be stable enough so that it won't have any movement. It should not happen that I am designing a building and and my foundations are on wheels. That if something force happens, the building is start move and it will be moving to infinite, because it will be having it is on wheels. It's not having any resisting capacity. So there won't be any force getting transferred, but it's unstable because of the wheels. It will start moving from one place to other place without any load getting transferred to that. So coming to the next part of it is bending. What we call as a bending, it's actually combination of tension and compression. So when we talk about force, the main is axial forces. That will be compression or tension. So the components of compression and tension combination is actually a bending. So one side getting compressed and other side getting tension is actually a bending. So what happens? What happens was when you are having a one log which has a two ends at 5 meters apart, and you start applying a load on it. So what happens? It will start bending down. So what happens? The bottom part will be in tension and top part will be in compression. So that's where the couple creates the bending. So that's the compression at the top and tension at the bottom will create a couple that will be transferred into a bending moment. So that's where the bending moment comes. It's not a direct force, it's an indirect tension and compression. So it will create indirect tension and compression. So that's where the bending action will come into the picture. So coming to the axial force, again the tension and compression, as you see in the right side top, when you pull a when you start making the member elongative, what happens? The member will start at the weakest point. It will start shrinking down, and at the peak capacity, it will break. So that's how the tension. When you start pulling if you take an elastic rubber and start pulling on both sides, the tension will be created. And if you observe that necking will be forming at a critical point where the elastic will break. So that's where necking is critical in tension. And coming to the compression will have two types, whether it's a collapsing compression like buckling of the element, or buckling of the element, or collapsing of the element. When we talk about collapse, it means crushing. So your material will start crushing due to this compressing force. So that is collapsible failure. And other way it is buckling, so which is for a longer elements. When you are applying you take any one second. So what happens was, when I take some block and I apply force on the top and bottom. So what happens? it will start crush. And what happen if I do the same size of the block of height, bigger height, what happens before it crush, it will start bending. So this is called buckling. So compression failure are two types. One is crushing when you are having a short columns, and if you are having a longer columns, what happens is before the crushing happens, buckling will happen. So that's where the difference between the if you call over tension, it's always due to necking. But when you talk about compression, it's a little different. It's collapsed by crushing in some cases where your members are very short, and if your members are so long, then there will be buckling phenomenon which is generated because of the length of the member. The more, if I do the same thing with a small member, so if I do the same thing with a small member with a more same load, the buckling will be more, because the ratio, the slenderness ratio, whatever we call the dimension of the column is getting weaker in bending. So that's where the buckling will be more in terms of a slender or longer member with a smaller diameter than a longer member with a bigger diameter than the shorter member with a bigger diameter. So that's where the buckling. So the buckling chances will be increased when you go for a longer member and a reduced diameter or reduced dimension for allowed for bending. So that's where the compression failure will happen. The tension failure is always through necking. The best example, you take elastic and you start pushing pulling out away, so there will be necking.
class.
So just briefing one more time, that the tension is actually when you are pulling the things away from each other, and compression when you are trying to push things away towards each other. And bending is an indirect phenomenon where the tension and bending. So this is the bending. When we call bending, the top fibers will be in compression, and when they start pushing towards each other, and bottom fibers will be in tension. They start pulled away from each other. So this is the way bending works. It's an indirect compression and tension where the lever arm is generating the bending moment. So that is where the bending is slightly different, but it's again the direct force like compression and tension. Tension and compression are direct forces. Bending is an indirect where the couple of tension and compression generates a bending. So this is a combination. And torsion is completely different. It's about rotation about its own central axis. So that's where the torsion is different with respect to the bending. So we discussed about the forces on individual members. So now we will discuss about forces on overall member, like or is a building. So what are the types of the forces? So coming to the forces on individual member, there are many types of loads: UDL, point load. Those are the type of the loads. And now coming to the forces, what are the type of the forces any building can attract? Like it can be anything. Like gravity. When you talk about gravity, it's nothing but the third law of motion, the gravitational force. So what is the gravitational force? It's nothing but m into g, mass into gravitational pull. The g is 9.81, and mass is the mass of the body. Any item which has a mass. So static force are again divided into two types. One is fixed force, fixed static, like walls, floors, thickness, concrete, dead weights. All these are called as static force. And dynamic, it's not dynamic actually. These are changing due to time. It's not dynamic because of the unnatural events. It's because of the changing with time. The people may go there or not go there. Furniture may move from here to here. So these are the dynamic forces. These are not related to dynamic with respect changing with time of the building, but it's with respect to the life of the building. So today the building may be serving as a residential building. Tomorrow it can be converted to office. So the loads of the office and the building will change, but the loads of the dead weights and the walls won't be changing. So that's where the static and non-static forces are different. So these are the two types of forces in terms of gravity, where some change with time or some doesn't change with time because of the life of the building or usage of the building, we can say. And other forces are unnatural forces, and which are not been known to everyone when it will come. It means it might be earthquake when you talk about seismic, and it might be wind or cyclones when you talk about wind loading. So what is the difference between the static and lateral forces? So these are actually dynamic, because these you don't know when will it occur and what is the building. These loads are not. When we talk about static, it's actually with respect to the time when the load is acting, there is no change in the load. Suppose if a man standing on the floor at t is equal to 0 and t is equal to 1 second, the load is same because the man is having same weight. The gravity forces are same because of the man. But when we talk about seismic, what happens was when your building starts shaking. So depending on your building shaking, the oscillation of the time period of oscillation is depending on the building geometry. But the shaking vibration is depending on the natural layers or whatever the layers underneath the building. So that decides what is the shaking vibration being caused onto the building. At t is equal to 0, it might be 1 kilonewton. At t is equal to 1.1 second, it might be 0.1 or it might be 2 kilonewtons, depending on the building behavior or the location where your building is suited. Like zone factor is the one thing which we call based on the geography of the India map. So they have divided the Indian plateau into 4 zones: 2, 3, 4, 5. The one is there initially, but that was discarded later after Bhuj earthquake. So that's one is out of the picture. So 2, 3, 4, 5 are the different zones where the seismic chance of seismicity and seismicity and the magnitude of seismicity is important. So the zone, when we call it zone, it depends on the what is the maximum oscillation the building can exhibit because of the earthquake on that particular area. So in Hyderabad, we call it as zone 2, and in Kakinada, Rajahmundry, we call it as zone 3, because the plateau there is much more having more vibrations than the plateau in Hyderabad. So that's where we call that if we go to Himalayas, that is zone 5. So the plateau is always vibrating, or the frequency of earthquakes are much bigger there, and the magnitude of earthquakes are much bigger there. So that's where the zone plays a major key role when we talk about earthquake. And coming to the importance of the building, if I'm if I'm creating a building for myself, it's a normal building. If I'm building a create for everyone, like it's a public building like airports, railway stations, communal centers, so there the importance factor will be much bigger. So I need that. So when we call about importance factor, what does it states? It states the importance of the building after earthquake. Suppose if there is if I build my one building where only 2 people are living, and that building is not designed for importance factor of 1.5, what happens? The building may collapse during earthquake. But when we talk about airports and communal centers, where that will act as a relief centers during these major natural calamities, those are important during that time. So they were designed for a higher importance factor. Like those buildings should be performed after earthquake. So as soon as the earthquake happens, the building should be still functional. But normal human being where 2, 3 people live, that doesn't need that performance after the earthquake immediately. There might be some repairs, and there will be some collateral damage. But when we talk about communal centers, airports, railway stations, these needs continuous operations during these activities. So they were designed for a more importance factor, like the importance factor of the communal buildings in India, where 200 people, more than 200 people are going to be there during earthquake, R is 1.5, and where less than 200 is there, that's 1. So you are designing your building 1.5 times more the earthquake, so that your building will be continued even with operations after the earthquake also. So coming to the third factor, which is having impact on the lateral force, is response factor. It again depends on the building geometry and the height of the building and everything. So the so that's where the response factor. So what is response is nothing but if I'm having a building with a so this is a building and this is a bridge. So this is a building and this is a bridge. Building are typically having the columns, multiple columns. But bridge, if you see most of the areas, it will be bridge of hammerhead, pier, and precast girders, you can say. So when I talk about what is the difference between these two, so the load might be changed, but the behavior but the main problem here is behavior. So in building, if one column fails, one column starts failing, so there will be redistribution happens to the other column. Building has number of columns, but bridge has only one column. So the number of the difference here is static indeterminacy. The static, if you remember the static indeterminacy, it depends on number of unknown values based on the static equations like sigma x equal to 0, sigma y equal to 0, sigma z equal to 0. So the more static indeterminate, the response will be, the much the response will be there. So your building will be less prone to failure during earthquake. But if you talk about bridge, it's in statically determinate. So it's going to be failed during earthquake, means it doesn't have any sharing property. The bridge is only one resting on one column. If that column fails, then bridge is collapsed. But in building, what happens, during earthquake, these all the columns will start participating each other and will start sharing the load if one starts failing. So that's where the building behavior is completely different to the bridge behavior. That's called the response. The response is depending on the static indeterminacy. The more static indeterminacy you have, the more response you can have. The way that's the area where you say the response spectrum is more, so that you will have lesser forces. And geometry is nothing but the height of the building and plan dimensions. And type of the building is nothing but steel or concrete or these things. The stiffness will be, the behavior will be different for different types of buildings. And coming to the wind load is nothing but during every day there will be winds, but the wind loading what we talk is about the 50-year life or 100-year life, depending on the importance of the structure. As I mentioned in the previous seismicity also, the importance of the structure will be deciding factor for the what is the written period of wind you are taking, whether it's 50 years, 100 years or 200 years, depending on the importance during the cyclones and everything. And topography is nothing but whether you are building on a hill, or you are building in a near the plain plateau. And the height is nothing but if you increase the height, obviously the wind is going to get increased. Geometry in seismic, the geometry is more on plan dimensions, but in wind the geometry is based on phase of the wind. So how much you obstruct the wind, that much only force you are getting. That's where, yes, Venkatesh. Hello? Venkatesh, you raised your hand. Anything?
Oh, nothing. Continue.
Okay,
Yes.
sorry. So wind, when you talk about seismic, the plan dimensions will play a major role. But you talk about wind, how much you are abstracting. Suppose if I am building a building which doesn't have any walls, it will be having nominal load. But in terms of earthquake, it will have the same phenomenon, same logic, and same behavior. But in wind, the load will be completely different depending on the obstructions you are getting created to the wind. So when there's a wind is occurring, if you are allowing it to pass it through you, then there will be no force getting transferred to the building. So that's where I call when load is getting transferred to force. If it is being obstructed, then only it will be transferred to the force. If it is not being obstructed, there is no force transfer. So that's as simple as that. So now coming to the one building, let's take a small building. What are the types of the building components we have? It might be beams, where the first one is slab, and slab being connected with the primary, secondary beams, and then primary beams, and then columns, and then load is transferred to the foundations. So these are the typical parts of a component, any building component in terms of structure. So the how load path is being transferred. So when you always the load is getting transferred from the slab only. So slab is the one which is in direct contact to the load. The slab will transfer to the load to the beam, and beam will transfer to the secondary beam will transfer to the primary beam, and then primary beam will transfer to the columns to the foundation, and foundation to the soil. So that's how the load transfer mechanism. So the first part is slab, which is getting impacted by the load straight away below the load, and then beam, and then column, and then foundation, and then soil. So this is the basic load path which everyone needs to understand for any building, any type of building. So we discussed on the building loads and everything. Now we talk about something related to materials. So what are the types of materials we can use when we are building a building? When we are creating a building. So that might be timber, wood, RCC means reinforcement concrete, or post-tension, pre-tension slabs, or steel structure, composite structure, and fiber reinforced structure. So these are the type of the construction. Very few type of construction. There may be multiple further also, but we'll talk into the more on the higher part. So coming to the wood construction, it is not predominantly working in India only for aesthetical points where someone wants to create something lavishly, or someone wants to create something beautiful in terms of view. That there the wood construction is predominant. Like India, we use wood as a finish material, not as a structural material, because of its properties and type of the quality of wood we have in India. and it will be lightweight, and it's more used in American and European countries because of the lightweight of the behavior of the lightweight and the aesthetics of the building. It's getting involved. In India, it is very low, and it's more used as a finished material, like on the floor you use a wood as a tiles or a flooring, so that you will have that feel of wood in the market. So this is the predominantly used in current Indian market, the reinforced cement concrete construction, RCC construction, where concrete and reinforcement will share the compression and tension. Concrete will take compression and reinforcement will take tension. But this has the more weight. When you talk about same structure of same utility, but this dead weight of the RCC will be much bigger when you compare it to all the types of construction we are getting talked. The PT is it's pre-tension or post-tension is little bit reducing in the weight of the concrete structure, but it's still on the top two. Like RCC will be in top one in terms of weight getting generated on the soil below, and PT will be standing in two. The composite steel and wood will come in the subsequent. So it will add more weight on the substructure. So when you're having, suppose when I'm having very loose sand or when I'm having very weak soil, so then RCC is building an RCC will be adding more weight to the structure. So that will be killing your capacities of the soil. So that much dead weight is going to come without any usage. Like I cannot. It's the dead weight is so much. Dead weight is nothing but to keep it in place. You need more weight than you are having a load. Suppose if I'm taking any RCC building, we are having a 125 thick slab. 125 thick slab, it's ultimately 375 kg per meter square of dead weight. 375 kg per meter square of dead weight, and what is the live load we are getting designed is 200 kg per square meter. So I'm using it for 200 kg per meter square of live load, but my dead weight itself is 375. So it's unavoidable that much weight I'm adding for the usage of 200. So actually I'm doing a double, I'm applying double weight of dead weight than actual live load which I'm being designed. I'm using, providing a building for live usage like people's furniture or anything. But actually the dead weight is so high that the live load will be very nominal in that case because of the RCC dead weights which we are getting. And it's cheaper in India. Cheaper in India, and this is the most prominently used in India because in India we have more labor and material is much cheaper than labor. And but labor is much cheaper than material. So that's where India has more RCC than steel or anything. But we go to European or American countries, there the labor is much costlier than the material, so they don't use RCC as much because the labor cost per hour is much bigger in those countries than in India, because in India we'll get a cheap labor. So we use RCC where the labor is quantum is more than the material. But in other countries where the material cost is more, the labor is very, very costly. So there they won't use RCC as a base material for design.
Sir?
Hello?
Sir?
Yes. Hello? Hello?
Sir?
Yes, yes, yes.
If in case labor cost in India is high, what to do, sir?
The same thing where what American countries are doing, like going to steel or composite. I'm coming to the topic. Just wait for 1 minute.
Okay, sir.
So now in India also we are so India see there is one more component before we talk about labor and material: time. So now India is more focusing on time, because when we talk about RCC, it will take, suppose for one slab it will take 20 days, but when you talk about steel structure, it will take just 5 days to erect. 5 days or 4-5 days it will take to erect. So that's where the time component is getting added to this. So when I talk about labor, material and time, India is now cashing on time. So now India wants a quicker building because of the market requirements. Like if I'm having a commercial complex where my rent is more than my, okay, 1 second. Hello? Yeah, in India, where if I'm building a commercial complex where my rent of the commercial space is much bigger, so then what happens? The time factor will come into the picture. There, what happens? I want to building faster than spending some money on the steel or composite or anything, because then comes the effectivity of time. When we talk about labor and material, those are still remaining as labor is cheaper and material is costly in India. But the time factor where I can sell my building much quicker. Like if I'm doing a steel construction, I will sell my building in 3 months advance. But the cost of the steel structure is 1.2 times or 1.3 times the RCC. Then what happens? Then I will take a call. What is the 3 months rent I am going to get because of making it early? So if the 3 months rent is more than the 20% or 30% I am investing on steel construction, then I will go with the steel construction. So that's where the people have understand the importance of time, and Indian market is having the potentiality where time is playing a key role. If I'm delivering faster, then I'm the one who is going to get good money. That by selling it or keeping it as a brand value, I can be quicker. So that's where Indian market is started investing on time. There, the steel and the steel construction has been grown up in India. If you see the recent ages, the more is coming in steel and composite structure. So steel, when you talk about steel, it's much more speeder. Like you can lift a slab in 5 days because all the things are planned on paper much better way. Because all steel, when you talk about steel, the fabrication happens in yard. Once your drawing gets completed, you can start fabrication from yard. So the quality control in steel is much bigger, and labor required at site are very less. The material will directly come and you just need to erect it and tighten it by bolts. That's it. So it's very simple when you talk about steel construction, but it's more costlier. When you compare to concrete, the steel is much more costlier. So that their Indian market is lagging behind. So Indian market is now thinking on whether to go for a higher cost or quicker. So that's where that type of construction will come into the picture. And somewhere in between comes the composite construction. What is composite? It's nothing but steel and concrete both together. So it has the benefits of both. It has lesser time, and the cost is also in medium in between both of these things, like steel and concrete. So this is much more getting prominent in current market. So if you see in coming 10 years, this composite construction is going to lead the market more than RCC, because it's quicker and it's comparatively less costlier than steel. And one more thing was, when we are walking on a steel, or the vibrations on or the feel of steel, or the human comfort on steel is very less. If you walk on any steel bridge or concrete bridge, you will feel the difference. When you walk on a steel bridge, you feel that you are vibrating, your buildings are you are getting vibrated. But when you talk about concrete, it's very nominal that you feel the vibration of the buildings. Because in concrete, what happens, your dead weight is so high and your live load is very nominal. So then what happens, your concrete dead weight is so high that your oscillations won't be counted in the building. Won't be counted. You cannot feel your vibration of the building or bridge when you're walking on a concrete. But what I was comparing to steel, the live load and the live load of the human vehicle or human is comparatively same as your what we call the structure weight. So then what happens, the frequency is very less. So you will feel those frequencies by yourself. So that the discomfort, even though it is not going to collapse, you will feel the discomfort when you are moving on a steel bridge or steel building. So that's where the discomfort is there in steel. But coming to the composite construction, it has the benefits of both, and it don't have any demerits as such. It's only that it will be little time consuming than steel construction, but it is better in a speeder construction. It will have the more frequencies, so that you won't feel that vibrations. So the human comfort is better compared to the steel construction, and it's in times of time it is better from the RCC construction. So this is the where the composite construction is going to run the market in the future, where you are having more composite construction than RCC. So that's where the India is getting focused on tomorrow, that composite is going to lead the market from the current RCC, because the time value of money is getting cleared in Indian market, that time is more valuable than money. Spending 1 rupee today, and if I'm getting delivered more faster, so that's more important to me than getting delayed and getting 2 rupees. So that's where the difference. So the time value of money is getting inbuilt into the people of business people, and they started building things faster, and they were getting more repay easier. So that's where the composite construction is going to play a key role in the future. So next, coming to the individual topic of beams. So coming to the beams, so now we will go in detail of each individual element which you talk: beam, slab, concrete, beam, slab, floor, and foundation. So coming to the beams are, you all know, it's simply supported, continuous, fixed, overhangs. So all these are types of the beams which you talk about. So these are the localized behaviors. So I'm not talking in the overall picture of building. It's again locally what are the types of building beam behaviors we can call. And you all know about shear force and bending moments. It's nothing but a resistance created by beam force getting created because of the slab, because of the load applied, and because of the resistance getting generated. Without resistance, there is no force. With resistance only, there will be force generated. So shear force is actually created because of the resistance of the shear, resistant to shear by a building, by a beam. Or bending moment is a force created because of resistance to bending of that particular beam. So that's where I call shear force and bending moments are actually the resistance, not the force. It's actually resistance because of the load applied. So how to calculate? You might all aware that how the shear force and bending moments are being calculated. So I'm not going into detail on that. And for different beams, this is for simply supported beam, how you calculate the shear force and how you calculate the bending moments. So this is how your shear force diagram looks, and this is how your bending moment diagram looks. And the same thing for the cantilever. This is how the bending moment and deflection curves looks. So when I say bending, that's where I'm saying the compression is at the top and tension is at the bottom. That's where the simply supported bending theory comes. And if you see the right side of the types of the beams, we are talking about cantilever, simply supported, overhanging, continuous, fixed, and proper cantilever and simply supported. So now coming to this, the bottom shapes are actually the deflected profiles. So the cantilever will deflect like this. So this is how the cantilever will deflect, because it's getting a fixed end here. It will have zero deflections and zero rotation here, and which is all bending. And if you talk about simply supported, it has zero deflections at the end, but it's going to bend maximum at the middle. And what is overhang? It's nothing but the load is applied on the spans are cantilevered in the over the simply supported beam. Then the beam will have a negative rotation at the supports and positive rotation at the bottom, at the in between. So this is how the overhang beams looks like. And this is how continuous
Sir,
beam. Yes. Yes. Hello. 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 Okay. Let me continue. So this is how continuous beams which you have the zero deflection at the ends, but negative rotation at the supports. So that's where the continuous beam deflected profile looks like. And fixed end beam, that it will have the negative rotation at the top, at the supports because of the fixity generated, and the positive rotation at the bottom. So that's that, and in between. So that's how the fixed end beam looks like. And cantilever and simply supported it's a proper cantilever. Proper cantilever looks like negative rotation at the supports because of the fixity, but zero deflection at the proper end. So this is how the cantilever looks like. It's nothing but a combination of this and this. So that's how so the deformations will govern the behavior. So when I talk about compression at the top and tension at the bottom, that's about when I say having a positive rotation or a positive bending moment. When we talk about hogging, that's about sagging. So this is how we call as sagging. But if I reverse this one, just mirror it, that's hogging. It will have tension at the top and compression at the bottom. So that is how the fixed and beam looks like. If I draw this negative slope curve of the fixed and boom, this is how it looks. So here it is having a negative bending moments and negative bending moments leading to negative rotation, and here we are having the positive bending moments leading to positive rotation. So here the tension will be at the top, here the tension will be at the bottom. So that's how the sagging and hogging plays a role, which decides the where I need to keep steel, because concrete is much stronger in compression than compared to steel. So that's where the concrete will take compression and steel will start taking tension. So you place steel cleverly on the tension phases so that you will have lesser use of steel, because steel is much costlier than compared to concrete. And coming to the slabs, so there are multiple types of slabs, like one-way slab, two-way slab, flat plate, waffle slab. So these are the much broader extents of what are the types of slabs. But when we talk about majorly, it's always a one-way slab or two-way slab. One-way slab, when we talk a one-way slab, the load will be distributed on both sides of the slab. Like if you see that this slab, the load is getting transferred to this direction only. This is not getting transferred to the other direction. But if you talk about two-way slab, it's getting transferred to the four directions. How this load get transferred? These so these are getting transferred because of these loads will be transferred based on the yield line theory. What is yield line? It's about a failure mechanism. So you take any paper, you understand the failure mechanism very easily. You take any paper and you apply a point load on a square paper. So then if you see the lines will be coming in this direction, So when if I take a paper, just take a paper of square shape and apply a point load at the center. So you will see that paper starts bending in this direction. It's a square paper. So the load will be distributed like this. So this part of the load will be distributed to this side of the beam, and this part of the load will be distributed to this side of the beam. So that is how the failure, depending on the failure theory or yield line theory, your load is getting transferred. If I take the same thing as a rectangle paper, what happens if you apply load at the center? That will be behaving something like this.
Hello, sir.
Yes.
I have a doubt, sir.
Yes.
Yeah, actually, in our houses, in many houses, there will be a crack for the slab, sir. What's the main reason for that, sir?
Which area? Depends on the area. See, if you observe a crack like this, you draw the, see, you take your house slab, whatever slab you are talking, just draw the slab. And if the cracks are in this, so if it's a square or one-way slab, depending on the type of the slab, you draw the failure curve. Suppose if I take your slab is two-way, like it's having a square dimension, it's having the 4-dimension beams. If you are having crack in this direction, then it's a structural failure in this direction. But if it's having somewhere in between, these are maybe shrinkage or temperature, so it might be anything. But if you see cracks along these directions, where we called yield line theory fails, this is how the actual slab failure occurs. So if these are cracks observed in these directions, your slab is getting failed because of structure. So that is a major problem. If these are the cracks, hairline cracks you observe here or here or here, so that is actually nominal temperature and shrinkage cracks, which you can chip it off and you apply plaster or mortar. But when you observe the cracks along the yield line, that's a failure. So that should be carefully attended by structure engineer. So that needs a support for you from structures.
Okay, sir. Thank you.
Thank you. Okay, now coming to the left side, you see the one-way slab. This is the failure theory. You will see that if you see a crack like this in this direction or in this location, that's a one-way slab is getting failed. If you see the two-way slab of a square shape, you will see cracks like this. So that is a two-way slab failure, two-way slab of failure theory. And if you see a rectangle slab, that will be seeing like this. So these are the failure and ideology of a one-way slab or two-way slab or two-way slab or two-way square shape and two-way unequal sides or equal sides. So that's how the load's getting transferred. So depending on this, so this, what I'm saying was, this is a failure curve of the slab. So this part of the load will be transferred to this side, and this part of the load will be transferred to this side, and this part of the load will be transferred to this side. So that's why here it was shown it's an unequal side. So the loads of this particular area will be transferred to this side of the beam, and this particular triangle will be transferred to this side, and this trapezium will be transferred to this side, and this triangle will be transferred to this side. So depending on the failure, the loads of the slabs have been distributed. And coming to the column, which we talked earlier, the column might be buckled, might be compressed, or might be shear. So these are the three different failures which we observe typically in any column. For buckling, it's more about the bending moment or the height of the column, depending on the ratio of the geometry. So that's where the buckling of the column and the reinforcement will play a major role in that. And you talk about compression, the concrete will take a major role in this compression failure. So you need a compression, you need more concrete dimensions or appropriate grade of concrete to avoid this compression failure. And your stirrups, actually when you talk about compression, your concrete is in compression, but what happens, your steel is also there, which is tying your concrete in place. So improper provision of your stirrups will lead to compression, buckling of your steel. So stirrups. So when I talk in terms of the reinforcement which I provide for a column, what is the difference? The longitudinal steel will actually help you to avoid you in buckling or bending of the column. But for your transfer steel will help you in a local buckling of stirrups or shear of the column. So when you talk about local buckling, what happens was your column is so long and you're having compression loads on concrete cross section, but your reinforcement is slow slender, that your reinforcement will start buckle. To avoid this buckling, the stirrups are provided, and to avoid the shear failure of the column, the stirrups are provided. So this is how and why The concrete, the reinforcement and stirrups are linked to the loads being applied or forces getting transferred. So these are the different types of column: rectangle column or square column, spiral column or circular column you call. This is tube in concrete and concrete filled encasement. These are the composite columns which we used for composite construction, where the steel tube will be filled with concrete or concrete will be filled inside with the steel section. So these are other types of load transfer in terms of beams also. So the truss analogy which will take the compression at the top and the bottom, and the incline will be taking the shear loads. So that is how the truss will work. And coming to the frame, the columns will be taking the columns will act as a fixed beam analogy, and you will have the bending moments accordingly. And the arch is actually, it will works on all compression. When you say arch, it actually transfer the loads in compression. Whatever load you apply, it will transfer into the compression only. That's where arch works. And initially, when you talk about initial areas, much predominant areas where rocks are used in construction, they will be using arch technology, where all the loads are transferred by compression, because rocks are only joined by compression. They are stronger in compression. But when you talk about rocks in tension, they won't help you much. So that's where the arch methodology is used much longer in the earlier days, not now. So coming to the foundation, so the foundation is nothing but the load getting from transferred column is getting transferred to the soil by parameter which are depending on soil or types of the loads we are getting. So it will behave as a smooth transfer between the column loads coming from the top to the soil, depending on the capacities and the properties of the soil. So foundation is actually a medium which gets transferred the force coming from the superstructure to the soil, which is with an effective way. Depending on the soil parameters, you will decide the type of the footing, whether it's a pad footing, step footing, slope footing, or a piles or combined footing, depending on the requirement of the loads, or depending on the how strong the soil is. That's how the foundation will work. So that's the end of the presentation. So any queries, please feel free to ask. So if I'm little fast, please avoid that, and please ask any queries. Hello.
Hi everyone. Sorry, ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా. If anyone is having any queries or any questions related to design, just ask now.
ఎవరికి డౌట్స్ లేవా? అడగండి, పర్లేదు.
Nagesh, anyone అందరికి క్లియర్ గా ఉందమ్మా? గణేష్,
ఓకే సార్.
పవన్, ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా. ఓకే,
నో డౌట్ సార్.
నో డౌట్స్ అంటే బాగా క్లియర్ గా ఉందా, అర్థం కాలేదా?
క్లియర్ గానే ఉంది సార్.
ఓకే, థ్యాంక్ యూ. Okay, so I will show one sample project which for your just reference. So let me open the project. సో మనకి ఎప్పుడైనా ఒక బిల్డింగ్ ప్లాన్ ఆర్కిటెక్ట్ నుంచి ఇలాగ వచ్చుద్ది మనకి. సో మనకి రూమ్ డైమెన్షన్స్ అన్ని తెలిసి మనకు వస్తాయి. సో మనం ఏం డిజైన్ చేస్తామంటే, ఈ రూమ్ డైమెన్షన్స్ బట్టి మన కాలమ్ పొజిషన్స్ ఎక్కడెక్కడ పెట్టుకుంటే మనకి ఎక్కడ లోడ్స్ ట్రాన్స్ఫర్ అవుతాయి, బీమ్స్ ఎక్కడెక్కడ పెట్టుకోవాలా, మనం ముందు ఒక బేసిక్ స్టడీ చేసుకుంటాం. బేసిక్ స్టడీ చేసుకొని దాని తర్వాత సో మనం బీమ్ సైజెస్, బీమ్ లొకేషన్స్ అనేవి మనం డిజైన్ చేసుకుంటాం. సో ఈ పొజిషన్స్ లో ఈ ఎల్లో కలర్ లో ఎక్కడైతే కనపడుతుందో అక్కడ ఈ ప్లాన్ బట్టి మనకు వచ్చిన ప్లాన్ ఆర్కిటెక్చరల్ ప్లాన్ బట్టి ఈ లొకేషన్స్ బట్టి మనం ఏమర్థం చేసుకుంటామంటే ఈ పొజిషన్స్ లో మనం కాలమ్స్ పెట్టచ్చు, ఈ పొజిషన్స్ లో మనం బీమ్స్ పెట్టచ్చు. అండ్ డిపెండింగ్ ఆన్ ద స్పాన్, అంటే ఇప్పుడు ఈ బీమ్ స్పాన్ ఎంత ఉందో దాన్ని బట్టి మనం బీమ్ డైమెన్షన్స్ డిసైడ్ చేసుకోవాలి. నార్మల్ గా స్పాన్ ఆఫ్ ద బీమ్ బై 20, 22, 25 బట్టి మనం బీమ్ డెప్త్ డిసైడ్ చేసుకుంటాం. స్లాబ్కి వచ్చేసరికి బై 20 to 26 మనకి IS 456 లో కొన్ని టేబుల్స్ ఉన్నాయి. చాప్టర్ 7 లోనే అక్కడ ఉంటాయి. 7 ఫర్ క్యాంటిలివర్, 20 ఫర్ సింప్లీ సపోర్టెడ్, 26 ఫర్ కంటిన్యూస్ బీమ్స్. దాన్ని బట్టి మనం బీమ్ డెప్త్లు, కాలమ్ డెప్త్లు, స్లాబ్ డెప్త్లు మనం డిసైడ్ చేసుకుంటాం. దాని తర్వాత ఒక బేసిక్ ఒక స్మాల్ క్యాలిక్యులేషన్ వేసుకుంటాం. కాలమ్ మీద ఎంత లోడ్ వస్తుంది ట్రిబ్యూటరీ లోడ్ ప్రకారం. సో ట్రిబ్యూటరీ లోడ్ అంటే ఏంటంటే ట్రిబ్యూటరీ లోడ్ అంటే ఏం లేదు. ఇప్పుడు ఈ కాలమ్ ఉంది, ఈ స్లాబ్ ఎలా ఫెయిల్ అవుతుంది అనుకున్నాం మనం, ఇలా అనుకున్నాం. ఈ స్లాబ్ ఇలాగా, ఈ స్లాబ్ ఇలాగా. ఇది క్యాంటిలివర్ కాబట్టి కొంచెం వెరైటీ, కొంచెం డిఫరెంట్గా ఉంటుంది. సో ఇలాగా ఇప్పుడు మనకి స్లాబ్ అని ట్రిబ్యూటరీ ప్రకారం మనం అర్థం చేసుకున్నాం ఎలా లోడ్స్ ట్రాన్స్ఫర్ అవుతుంది. సో ఇప్పుడు ఏమవుద్ది, ఇప్పుడు ఈ కాలమ్ మీదకి లోడ్ అంటే ఏంటి, ఈ ట్రిబ్యూటరీ మొత్తం ఇప్పుడు ఈ బీమ్కి వచ్చేస్తుంది. ఈ ట్రిబ్యూటరీ అంతా ఈ బీమ్ మీద కొనుకొచ్చుద్ది, ఈ ట్రిబ్యూటరీ అంతా ఈ బీమ్ మీదకి వచ్చింది. ఈ బీమ్ ఏం చేస్తుంది, సగం ఇటు సగం ఇటు. సో కాలమ్ మీదకి వచ్చే లోడ్ ఏమవుద్ది, ఈ ట్రిబ్యూటరీలో సగం, 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 ఈ ట్రిబ్యూటరీలో సగం. సో ఇదంతా ఈ లోడ్ అంతా మనకి ఈ కాలమ్ మీదకి వచ్చింది మనకి. సో మనం ఏం చేస్తామంటే ఫస్ట్ మనం ట్రిబ్యూటరీస్ డ్రా చేసుకొని దాని తగ్గట్టు మనం ఈ కాలమ్ మీదకి లోడ్ ఎంత వచ్చిందో మనం ఎస్టిమేట్ చేస్తాం. కాలమ్ మీదకి లోడ్ ఎంత వచ్చిందో మనకి ఎస్టిమేట్ అయిపోతుంది కదా, నెంబర్ ఆఫ్ ఫ్లోర్స్ బట్టి అక్కడ ఉన్న లోడ్ బట్టి. దాన్ని బట్టి మనం కాలమ్ మీద వచ్చే లోడ్ బట్టి మన కాలమ్ సైజ్ అనేది డిసైడ్ చేసుకుంటాం అనమాట. సో మనకి సపోజ్ 2 ఫ్లోర్లు ఉన్నాయి, ఒక్కొక్క ఫ్లోర్ లో మనకి స్లాబ్ వెయిట్ ఎంత, బీమ్ వెయిట్ ఎంత. సో ఈ ట్రిబ్యూటరీలో వచ్చే స్లాబ్ వెయిట్ మొత్తం ఈ కాలమ్ మీదకి వచ్చింది. ఈ ట్రిబ్యూటరీలో ఈ గ్రీన్ బాక్స్ లో ఉన్నంత వెయిట్ కాలమ్ మీదకి వచ్చిందని మనం డిసైడ్ చేసుకొని దాన్ని బట్టి కాలమ్ సైజ్ అనేది మనం బేసిక్ అనాలిసిస్ బట్టి మనం స్టడీ చేసుకుంటాం. దాని తర్వాత మనం 3D మోడల్ ప్రిపేర్ చేస్తాం, దాన్ని బట్టి మనం చేస్తాం. సో ఇది మన ఫస్ట్ స్టెప్స్ అనమాట. ఫస్ట్ మనం కాలమ్స్ ఎక్కడ పెట్టుకోవాలి, బీమ్స్ ఎక్కడ పెట్టుకోవాలి, వాల్స్ ఎక్కడ వస్తున్నాయి, దాన్ని బట్టి బీమ్స్ ఎక్కడ ఉన్నాయి. దాని తర్వాత దాన్ని బట్టి ట్రిబ్యూటరీ బట్టి దాని సైజెస్, బీమ్ సైజెస్. ఇప్పుడు బీమ్ సైజు, ఇప్పుడు ఈ బీమ్ లెంత్ ఇదంతా బీమ్ స్పాన్, ఇది వచ్చరికి ఈ బీమ్ స్పాన్. దీన్ని బట్టి మన బీమ్ సైజ్ ఎంత ఉండాలి, ఈ సైజ్ చూడండి ఇది పెద్దది, ఈ స్పాన్ పెద్దది. సో ఇక్కడ బీమ్ సైజ్ డిఫరెంట్ ఉండాలి, ఇక్కడ బీమ్ సైజ్ డిఫరెంట్ ఉండాలి. దాన్ని బట్టి మనం అనాలిసిస్ చేసుకుంటాం అనమాట. అనాలిసిస్ చేసుకొని మనం దాన్ని బట్టి బీమ్ సైజెస్, కాలమ్ సైజెస్ తెచ్చుకుంటాం. దాని తర్వాత మనం ఒక అదేంటి మనకి రఫ్ ఎస్టిమేషన్ వచ్చేది అనమాట. దాని తర్వాత దాన్ని రన్ చేసుకుంటాం. రన్ చేసుకొని మనం చెక్ చేసుకుంటాం మనం అనుకున్న సైజెస్ ప్రకారం ఇవి వర్క్ అవుతున్నాయి లేవా, డిఫ్లెక్షన్స్ పాస్ అవుతున్నాయి లేవా, స్టీల్ కరెక్ట్ గానే వస్తుందా, మరీ ఎక్కువ వస్తుందా, మరీ తక్కువ వస్తుందా. మరీ ఎక్కువ వస్తే ఏమవుద్ది, మీకు కాస్ట్ ఎక్కువ కాబట్టి స్టీల్ ప్రాజెక్ట్ కాస్ట్ పెరిగిపోద్ది. మరీ తక్కువ వస్తే ఏమవుద్ది, కాంక్రీట్ కాస్ట్ పెరిగిపోద్ది. సో మనం మధ్యలో ఉండాలన్నమాట. సో మరీ ఎక్కువ రాకూడదు, మరీ తక్కువ రాకూడదు. సో మధ్యలో మనం మోడరేట్ గా మనం డిజైన్ చేసుకుంటూ దాని తగ్గట్టు మనం సైజ్ అనేది ఫిక్స్ చేసుకోవాలి. ఫిక్స్ చేసుకున్న తర్వాత అనలిటికల్ మోడల్ ప్రిపేర్ చేసి దాంట్లో లాటరల్ లోడ్స్ అంటే ఎర్త్క్వేక్ లోడ్స్, విండ్ లోడ్స్ వేసి రన్ చేసుకుంటాం. సో ఇప్పుడు నేను రన్ చేసింది సో ఇది ఒక ఫ్లోర్ మోడల్. ఒక ఫ్లోర్ మోడల్ ని మనం అందరూ ఏం చేస్తాం, రెప్లికేట్ చేసి మనం 3 ఫ్లోర్స్ దీన్నే మనం డూప్లికేట్ చేసుకుంటూ వెళ్ళి మనం 3 ఫ్లోర్స్ క్రియేట్ చేసుకుంటాం అనమాట. 3 ఫ్లోర్స్ 2 ఫ్లోర్స్ డిపెండింగ్ ఆ బిల్డింగ్ జామెట్రీ అంటే దాన్ని బట్టి మనం నెంబర్ ఆఫ్ ఫ్లోర్స్ అని డిసైడ్ చేసుకుంటాం. సో మనకి ఫస్ట్ కాన్సెప్ట్ వైజ్ డైమెన్షన్స్ అనేవి మన మాన్యువల్ గానే వచ్చేస్తాయి. కాకపోతే మనం వచ్చిన సైజెస్ కొంచెం అటు ఇటుగా ఒక 10 to 15% మనం 3D మోడల్ ప్రిపేర్ చేస్తే మనకి ఎగ్జాక్ట్ తెలుస్తాయి అనమాట. మనం మాన్యువల్ గా చేసే అజంప్షన్స్ వేరు, మన అనలిటికల్ మోడల్ ప్రకారం అనలిటికల్ మోడల్ కూడా పాయింట్స్ అయ్యే లోడ్ పాత్రలు అన్ని అలాగే ఉంటాయి, అన్ని అలాగే ఉంటాయి. కాకపోతే ఏంటంటే ఇంకా బెటర్ మనకి మాన్యువల్ ఎర్రర్స్ లేకుండా ఇది 3D మోడల్ ప్రిపేర్ చేసుకున్నాను. 3D మోడల్ అంటే ఇది G+1 బిల్డింగ్. సో గ్రౌండ్ ఫ్లోర్ లో మనకి స్లాబ్ ఏ ఉండదు కాబట్టి ఓన్లీ ప్లింత్ బీమ్స్ ఉంటాయి. ఫస్ట్ ఫ్లోర్ స్లాబ్, టెర్రస్ స్లాబ్, దాన్ని బట్టి ఇది స్టేర్ కేసులు అన్ని వేసుకున్నాను. దాని తర్వాత ఏమవుతుంది, ఇప్పుడు మనకి బీమ్ సైజులు అన్ని నేను తీసుకొని దాంట్లో చేశాను. ఇప్పుడు మనకి దీని నుంచి మనకి రెయిన్ఫోర్స్మెంట్ వచ్చేది ఎంత వచ్చిందో ఎంత కావాలో మనకు వచ్చేసింది. సో ఇప్పుడు ఇది ఇక్కడ లోడ్ ఒక సేమే, కాకపోతే ఇక్కడ చూడండి మీకు 700 mm², అంటే 700 mm² స్టీల్ వస్తుంది, ఇక్కడ 900 వస్తుంది. ఎందుకంటే ఇక్కడ వచ్చేసరికి మనకి స్పాన్ ఎక్కువ, ఇక్కడ వచ్చేసరికి స్పాన్ తక్కువ. నెక్స్ట్ ఈ బీమ్ తో కంపేర్ చేస్తే ఈ బీమ్ లో ఎక్కువ వస్తుంది, తక్కువ వస్తుంది, ఎందుకంటే ఇదేమో క్యాంటిలివర్ లోడ్స్ ఎక్కువ ఉన్నాయి ఇక్కడ, సో ఇక్కడ టార్షన్ ఎక్కువ వచ్చింది. సో అందుకని ఈ బీమ్ లో కొంచెం స్టీల్ ఎక్కువ వస్తుంది, ఈ బీమ్ లో తక్కువ వస్తుంది. ఈ బీమ్ తో కంపేర్ చేసుకుంటే ఈ బీమ్ లోడ్ ఎక్కువ కాబట్టి, స్పాన్ ఎక్కువ కాబట్టి దాని తగ్గొచ్చు వస్తుంది. సో అలా అనమాట. ఇప్పుడు మనకి సో మీకు చెప్పా కదా అది ట్రయాంగిల్ ట్రెపిజియం గురించి. ఇదేమో స్క్వేర్ ప్యానల్. ఇక్కడ వచ్చే సిస్టమ్ కనుక మీకు రాంబస్లు వస్తాయి ఎక్కువ, ఇక్కడ వచ్చేసరికి కొంచెం ట్రయాంగిల్ వస్తుంది. సో నేను చెప్పినట్టు మనం మాట్లాడుకున్నట్టు ఈ లోడ్ వచ్చేసరికి ట్రయాంగిల్ ఎక్కడికి వెళ్ళిపోయింది, ఇది ట్రయాంగిల్. ఇది చూడండి, ఇది వచ్చేసరికి మీకు ఇక్కడ వచ్చేసరికి ట్రయాంగిల్ లోడింగ్ వచ్చింది, యూవీఎల్ వచ్చింది. ఇక్కడికి వచ్చేసరికి యూవీఎల్ వచ్చింది, మధ్యలో కొంచెం యూడీఎల్ వచ్చింది, ఎందుకంటే ఇక్కడ హారిజాంటల్ ఎక్కువ. అదే ఇక్కడ చూస్తే కనుక మీకు చాలా ఎక్కువ ఉంది హారిజాంటల్. సో అందుకని మీకు ఏమొచ్చింది, ఇక్కడ చాలా ఎక్కువ వచ్చింది. ఇక్కడ ఇది ఇలా వెళ్ళిపోయింది. ఇక్కడ మీకు హారిజాంటల్ పోర్షన్ ఎక్కువ వచ్చింది కాబట్టి ఇక్కడ మీకు ఈ బీమ్స్ లో చూస్తే మీకు హారిజాంటల్ పోర్షన్ ఎక్కువ ఉంది. సో ఇదంతా యూవీఎల్, ఇది వచ్చరికి యూడీఎల్, ఇది వచ్చరికి మళ్ళీ యూవీఎల్. ఇలా సేమ్ అనాలజీ ఫాలో అవుద్ది, కాకపోతే ఏంటంటే కొంచెం బెటర్ ఇది కంప్యూటర్ బేస్డ్ కాబట్టి కొంచెం డిఫరెంట్గా ఉంటుంది అంతే. ఓకే, అండ్ నెక్స్ట్ మనం మోడల్ చేసుకున్న తర్వాత దీన్ని మళ్ళీ మనం టెక్నీషియన్స్కి ఇస్తే వాళ్ళు డ్రాఫ్టింగ్ చేస్తారు. మనం డ్రాఫ్టింగ్ చేస్తే మనకి ఇది ఫైనల్ బిల్డింగ్ అనమాట. ఇది యాక్చువల్లీ ఇందాక చూసిందేమో మీరు అనలిటికల్ మోడల్, అంటే ఇందాక చూసిందేమో మనది అనలిటికల్ మోడల్. ఇది వచ్చి అనలిటికల్ మోడల్ ఎక్కడైతే మనం నెంబర్స్ రన్ చేసుకుంటాం, స్ట్రక్చర్ అనాలిసిస్ మోడల్స్ డిజైన్ ఇక్కడ చేసుకుంటాం. దాని తర్వాత దానికి డ్రాయింగ్ ఫార్మాట్ లో క్రియేట్ చేయడానికి మళ్ళీ మనకి 3D షేప్, ఇది వేరే మోడల్. సో ఇక్కడ వచ్చేసరికి 3D లో మనం బిల్డింగ్ అంతా డ్రా చేసుకొని దాని తగ్గట్టు మనం కాలమ్ ప్లాన్, ఫౌండేషన్స్ అంతా డిజైన్ చేసుకుంటాం. ఫౌండేషన్స్, గ్రౌండ్ ఫ్లోర్ లో బీమ్ సపోర్ట్, ఇది డ్రాయింగ్ అవుట్పుట్, ఇది అవుట్పుట్ అనమాట. మనం చేసే మోడల్ అది 3D మోడల్, అది అనలిటికల్ మోడల్. ఇది వచ్చేసరికి ఇదేమో ఇది డాక్యుమెంటేషన్ అనమాట, డ్రాయింగ్ ఫార్మాట్ లో క్రియేట్ చేయడానికి ఒక్కొక్క ఫ్లోర్ కి మనకు ఒక ఫ్రేమింగ్ ప్లాన్, డ్రాయింగ్స్ అవన్నీ వచ్చేస్తాయి అనమాట. సో దట్ ఈస్ ద మెయిన్ ప్రాసెస్ హౌ వి ఫాలో. అవి మీకు ఇప్పుడు డౌట్స్ ఏమైనా ఉంటే అడగండి, లేకపోతే కనుక మనం వైండప్ చేద్దాం. హలో,
నిరంజన్ మ్యూట్ చేసుకోమా. నిరంజన్, okay Pavan, give me the host.
Okay, somebody asked about a question on wood, chat lo ganaka. Manoj Kumar, you said that మీరు అడిగింది ఏంటంటే బ్యాంబూ కొన్ని ప్లేసెస్ లో యూజ్ చేస్తున్నారు అన్నారు. స్టీల్ తో కంపేర్ చేస్తే అది రెయిన్ఫోర్స్మెంట్ సేమ్ అని. బ్యాంబూ is also can be used as reinforcement in some places. There are some CPW, some government allows bamboo as a reinforcement. Reinforcing nothing, reinforcement అంటే ఏం లేదు మనకి.
Pavan, once mute all and then mute.
సో బ్యాంబూ అనేది మనకి రెయిన్ఫోర్స్మెంట్ లో పెద్ద డిఫరెన్స్ ఏం కాదు. సో బ్యాంబూ వచ్చేసరికి ఏంటంటే కొంచెం వీక్, స్ట్రెంత్ తక్కువ ఉంటుంది. సో నీకు సేమ్ లోడ్స్ కి నువ్వు బ్యాంబూ ఎక్కువ పెట్టాల్సి వచ్చింది, అంతే డిఫరెన్స్. అండ్ నెక్స్ట్ రెయిన్ఫోర్స్మెంట్ ఎందుకు వాడతారు కాంక్రీట్ లో అంటే థర్మల్ ఎక్స్పాన్షన్ అండ్ కాంట్రాక్షన్. ఇప్పుడు మనకి రెండు మెటీరియల్ మనం కలిపి పెడుతున్నప్పుడు ఆ రెండు మెటీరియల్ కి సేమ్ థర్మల్ ఎక్స్పాన్షన్ ఉంటే కనుక ఎక్స్ట్రా స్ట్రెసెస్ క్రియేట్ అవ్వవు. అదే రెండు మెటీరియల్ డిఫరెంట్ అయితే కనుక మనకి థర్మల్ స్ట్రెసెస్ ఎక్కువ వస్తాయి అనమాట. సో ఆఫ్ ఆల్ ద మెటల్స్ స్టీల్ కి కాంక్రీట్ కి దగ్గరలో ఉంటాయి థర్మల్ కోఫిషియన్స్. అందుకనే రెయిన్ఫోర్స్ కాంక్రీట్ స్టీల్ లో స్టీల్ పెడతారు. మీరు రెయిన్ఫోర్స్మెంట్ కెన్ బి ఎనీథింగ్. రెయిన్ఫోర్స్మెంట్ అంటే ఏంటి? స్ట్రెంత్ ఇవ్వడం అంటే. కాంక్రీట్ స్ట్రెంత్ ఇవ్వాలి. కాంక్రీట్ ఎందులో వీక్? టెన్షన్ లో వీక్. సో టెన్షన్ లో ఏదైనా పెట్టచ్చు. నువ్వు బ్యాంబూ పెట్టచ్చు. నేను మీకు టాపిక్ అందులో మీకు చూపించాను, ఫైబర్ రెయిన్ఫోర్స్మెంట్ అని. ఫైబర్ రెయిన్ఫోర్స్మెంట్ అంటే ఫైబర్స్ పెడతారు. అవి ఫైబర్స్ అంటే ఏం లేదు, పాలిమర్స్, మనం రబ్బర్స్ వాడతాం కదా, అలాంటివి ఉండొచ్చు. చిన్న చిన్న మెటల్ వైర్స్ ఉంటాయి. సో అదేంటంటే ఫైబర్ రెయిన్ఫోర్స్డ్. అల్టిమేట్ గా మన మెయిన్ ఎయిమ్ వచ్చేసరికి కాంక్రీట్ ని రెయిన్ఫోర్స్మెంట్ చేయాలి, రెయిన్ఫోర్స్ చేయాలి. రెయిన్ఫోర్స్ అంటే స్ట్రెంత్ ఇవ్వాలి. అది రెయిన్ఫోర్స్మెంట్ వాడచ్చు, ఫైబర్స్ వాడచ్చు, మెటల్ వైర్స్ వాడచ్చు, బ్యాంబూ వాడచ్చు. కాకపోతే డిఫరెంట్ మెటీరియల్స్ కి డిఫరెంట్ బిహేవియర్లు ఉంటాయి. దాని తగ్గ డిజైన్ మారుతుంది. అంతేగాని ఇట్స్ ఆల్ అవుట్, నో ప్రాబ్లమ్ ఇన్ దట్. ఓకే వెంకటేష్, యు ఆర్ ద హోస్ట్.
ఓకే, థ్యాంక్ యూ పవన్. ఇట్స్ వెరీ గుడ్. ఓకే, ఎవరికైనా ఏమైనా డౌట్స్ ఉంటే అడగండి అమ్మా, లేదంటే విల్ క్లోజ్ ద సెషన్ ఫర్ టుడే. ఐ హోప్ అందరూ స్ట్రక్చరల్ ఇంజనీరింగ్ కోసం హౌ వీ ఫాలో ఇన్ ఇండస్ట్రీ, లైక్ బేసిక్గా క్లాస్లో చదువుకుంటారు. IS 456 యూస్ చేసుకుని ఒక బిల్డింగ్ డిజైన్ చేయడం, IS 800 యూస్ చేసి స్టీల్ స్ట్రక్చర్ డిజైన్ చేయడం ఆల్రెడీ మీరు నేర్చుకున్నారు. సో బట్ హౌ ఎగ్జాక్ట్లీ ఇట్ హ్యాపెన్స్ ఇన్ అవర్ ఎండ్. సో ఒకసారి ఒక కన్సల్టెన్సీ కానీ ఒక ఇండస్ట్రీకి కానీ వచ్చిందంటే ఇట్ చేంజెస్ అనమాట. సేమ్ ప్రిన్సిపల్స్ యూస్ చేస్తాము, సేమ్ కోర్స్ ఫాలో అవుతాము, బట్ ఇట్ విల్ బి రిగరస్ కైండ్. సో వెన్ యూ సీ విల్ యూజ్ లాట్ ఆఫ్ సాఫ్ట్వేర్స్, ఏదైనా సాఫ్ట్వేర్ యూస్ చేసి అనలిటికల్ మెథడ్స్ అని యూస్ చేసి చేస్తాము. సో యూ హ్యావ్ టు లెర్న్ ఎవ్రీథింగ్ ఇన్ ద ప్రాసెస్ ఆఫ్ యువర్ ఎడ్యుకేషన్ ఓన్లీ. అంటే ఇప్పుడు డిప్లొమా చేస్తున్నారు కాబట్టి ఇంకా స్టార్టింగ్ స్టేజ్లో ఉన్నారు. నెక్స్ట్ బీటెక్, ఎంటెక్ ఇట్లాంటివి ఇవన్నీ చేసినప్పుడు మీరు ఇవన్నీ కూడా ఫేస్ చేస్తూ ఉంటారు. సో ఇఫ్ ఎనీవన్ ఈజ్ ఇంట్రెస్టెడ్ in structural designing also, later after your training we can give you some tasks. మీరు కూడా అవి చేస్తూ ఉండొచ్చు. anyone interested only, not all the people. Okay, so as of now Pavan gave a very good presentation. Pavan gave very informative things to you. సో అసలు స్ట్రక్చరల్ ఇంజనీరింగ్ అంటే ఏంటి, ఫోర్సెస్ ఎలా ఉంటాయి, బిల్డింగ్స్ ఎట్లా డిజైన్ చేస్తారు, వాట్ ఆర్ ద assumptions we have to consider while we are fixing the sizes of the structure, members, ఇలాంటివన్నీ కూడా ఈరోజు తెలుసుకున్నారు. సో now what we do is we'll post a recorded session. if anyone miss అయిన వాళ్ళు కూడా ఫాలో అవ్వమని చెప్పండి. సో from tomorrow what you are going to do is I will give a group tasks. మీకు గ్రూప్ టాస్క్స్ ఇస్తాను. అందులో మేజర్గా ప్లానింగ్ అండ్ ఎస్టిమేషన్స్ అండ్ కన్స్ట్రక్షన్ మెథడ్స్ మీద వర్క్ చేస్తారు. స్ట్రక్చరల్ డిజైన్ మెథడాలజీ కోసం కూడా జస్ట్ దాంట్లో మీరు IS 456 యూస్ చేసి ఏం చేస్తారో అనేది ఒక ఎక్స్ప్లెనేషన్ కూడా ఇస్తే సరిపోతుంది. స్ట్రక్చరల్ డిజైన్ చేయడానికి మీ దగ్గర లైక్ సపోర్టింగ్ సాఫ్ట్వేర్స్ అవి ఉండవు కాబట్టి ఈరోజు ఎలా చేస్తారనేది చూపించాము, బట్ ఆ మెథడాలజీ ఎలా చేయాలి ఏంటనేది నేను ఎక్స్ప్లెయిన్ చేస్తాను. సో విల్ గో అహెడ్ విత్ ద గ్రూప్ టాస్క్ ఫ్రమ్ టుమారో. ఓకే, సో ఎవ్రీవన్ బీ అవైలబుల్ విత్ మీ. సో రేపటి నుంచి మనం గ్రూప్ టాస్క్లో కంటిన్యూ చేద్దాం. సో థ్యాంక్ యూ పవన్, థ్యాంక్ యూ ఫర్ యువర్ టైమ్. సో ఇట్స్ వెరీ గుడ్ ప్రెజెంటేషన్ టుడే. ఓకే,
నో ప్రాబ్లం, ఇట్స్ మై ఆనర్.
ఓకే, ఎనీవన్ ఇఫ్ యూ ఆర్ హ్యావింగ్ ఎనీ డౌట్స్ యూ క్యాన్ పోస్ట్ ఇన్ ద వాట్సాప్ గ్రూప్. పవన్ సార్ కూడా గ్రూప్లోనే ఉన్నారు ఆల్రెడీ, వాట్సాప్ గ్రూప్లో. ఏమైనా ఉంటే మెయిల్ చేయొచ్చు, ఫోన్ చేయొచ్చు, ఎనీథింగ్. ఓకే, యూ జస్ట్ ఆస్క్ ఎనీథింగ్ ఎనీ టైమ్ ఫ్రీలీ. మీరు ఏ టైంలో ఏం అడిగినా సరే మేము రెస్పాండ్ అవుతాము. ఎవరికైనా ఎటువంటి డౌట్స్ ఉన్నా, ఏమన్నా గైడెన్స్ కావాలి అన్నా జస్ట్ ఆస్క్ us in the WhatsApp group. Okay, so see you tomorrow. Okay then, with everyone. Bye. I'm closing the meeting right now.
Thank you.